Let's talk about how to balance chemical equations. So the fourth way we can represent a chemical equation is in a balanced chemical equation. It's kind of like the skeleton equations we talked about in the last section, but it is showing that the law of conservation is upheld. So we remember that atoms can't be created or destroyed in an ordinary reaction. All the atoms that we start with, we must end up with. A balanced equation has the same number of each element on both sides of the equation. So there's some rules that we need to follow to correctly balance equations. First is we need to assemble the correct formula for the reactants and products using all appropriate symbols. Now, sometimes this is done for you. Sometimes you have to do it, you have to take the words and turn them into the correct formulas and then balance. Next, we need to count the number of atoms of each type appearing on both sides. Then we balance the elements one at a time by adding coefficients. Those are the numbers in front where you need more. A helpful hint is to save balancing hydrogen and oxygen until last. I like to save oxygen for the very last. It just works out better that way. And the last step is to double check to make sure it's balanced. The only way to get a balanced chemical equation wrong on a test is to leave it wrong. I know you can all multiply and add, and if your numbers don't equal on both sides, then you shouldn't move on to the next question. You should erase everything and try again. Never, when you're balancing equations, can you change a subscript to balance the equation. You can only change the coefficient. For example, if I had H2O, that's water, but if I was balancing the equation and I needed an extra oxygen, I can't just add a little 2 with the other on the end of the oxygen there. H2O2 doesn't mean water anymore. It means hydrogen peroxide. It's a completely different chemical. Also, you can never put a coefficient in the middle of a formula. You can only go in front. For example, a little 2 in front of NaCl is okay. That means you have 2 sodium chlorides. But you can't put a big 2 in the middle. Na2Cl is not okay. That's not possible. You can't do that. So next I have some practice examples for you to do. The best way to get good at balancing equations is just to do them. You can watch me do a couple and eventually you can pause the video and try to balance them on your own. So we'll practice some here, and we'll definitely practice a lot in class. This is something that takes some practice to get good at. But let's just jump right in and get started here. So in this first equation here, I have 1 Ag on the left, 1 Ag on the right. So that's balanced. I have 1 Cu on the left, 1 Cu on the right. That's balanced. But on the left, I have 1 NO3. Now this is a polyatomic ion. This is nitrate. I like to treat polyatomic ions as just if they're another chemical in the equation. You could balance each element individually, but it's just easier to treat it as one. So I have 1 nitrate on the left, and I have 2 nitrates on the right. So we'll put a little 2 right here to balance it out. But by putting a 2 here, this changed my number of silvers. I now have 2 silvers on the left and only 1 on the right. So that's an easy fix. We'll just put a 2 in right there. Okay, let's do the next one. Mg plus N2 makes Mg3N2. So I have 1 Mg on the left, 3 Mg's on the right. So we'll put a little 3 in front of this Mg here, and I believe we're done. I have 2 nitrogens on the left and 2 on the right. So yeah, this one's balanced. Let's move on to the third one. I have 1 phosphorus on the left, 4 phosphoruses on the right. So that's an easy fix. We'll just put a 4 there. On the left, I have 2 oxygens. On the right, I have 10 oxygens. So I'll need to change this coefficient to a 5. So 5 times 2 is 10 oxygens on the left, 10 on the right. Okay, the next one. I have 1 sodium on the left, 1 sodium on the right. I have 2 hydrogens on the left, and on the right I have these 2 plus this one. That's 3 hydrogens, so that's not balanced. The oxygens are balanced. I have 1 oxygen on the left, 1 oxygen on the right. Okay, so this can be tricky sometimes. When you have an even number on the left, like 2, and then an odd number on the right, like 3, the strategy is you need to get them both up to an even number as fast as you can, as easy as you can. So if I have these 2 hydrogens, if I put another 2 here, I then have 2 hydrogens plus these 2, that's 4. That's an even number. Now I can multiply something, I can use the coefficient to multiply by this to bring it up to 4, and that would be a 2. Okay, but by putting this 2 here, I changed my number of sodiums. I have 2 sodiums on the left, or on the right rather, and I only have 1 on the left. So I'll put a 2 in front of that sodium there. And I believe we are now balanced. Okay, the last one is 1 carbon on the left, 1 on the right, 4 hydrogens on the left, 2 on the right, 2 hydrogens on the left, and then 2 plus 1, that's 3 on the right. So, or oxygens. 2 oxygens on the left, 3 on the right. So let's do the hydrogens first. So I'll put a 2 here to balance that. 2 times 2 is 4 hydrogens on the right, 4 hydrogens on the left. Putting this 2 here is going to bring our odd number of oxygens up to an even number, so that's helpful. 2 oxygens plus these 2 is 4. Over here I have 2, so this is an easy fix. We'll put a coefficient 2 here. 2 times 2 is 4 oxygens, and we're balanced. So these are all correctly balanced. If you tried some of them on your own and had different numbers, but you thought they were balanced, one issue might be is that you don't have it in the lowest possible whole numbers. So for example, in this bottom one here, if you had 2, 4, 2, 4, if you counted those numbers, it would still be balanced, but it's not in the lowest possible whole number ratio. If that isn't the case, unfortunately, it's not a correct answer. So when you're done, especially if you had a hard equation that you struggled with for a while, double check to make sure that it's in the lowest whole number coefficients, or you'll get it incorrect. Okay, I have one more type of balancing equation that I want to show you. This is a special type of problem. Okay, well, let's just start and then I'll show you what I mean. You might run into this and I'll show you the strategy for how to fix it, how to get it correct. Okay, so on the left I have 5 carbons, on the right I have 1 carbon. So we'll put a 5 there, that's good. So the hydrogens, I have 7 hydrogens on the left and 7 plus 1, that's 8 hydrogens. So 8 hydrogens on the left, and I have 2 on the right. So if I put a 4 here, now that's 4 times 2, 8 hydrogens. All right, like I said, always save oxygen for last because this type of problem shows up with oxygens a lot. So 4 oxygens plus these 10, 5 times 2 is 10, plus 4 is 14 oxygens. On the right, I have 2 oxygens plus this one is 3. So I have 3 on the left and 14 on the right. There's not a single number I can add here that's going to fix this problem. This is what we call the odd-even problem. 3 and 14 is an odd number on one side, an even number on the other. So when you run into this type of problem, what you should do is, first step is to double everything. Double every number except for the one you're having trouble with. In this case, it'd be the oxygen. Okay, so there's nothing here, but really this coefficient is a 1. We wouldn't write this formula if there wasn't at least one of them. So this is really a 1. We're going to double it to a 2. Okay, remember, skip the one that you're stuck on, but the other ones that you've already balanced double. So this 5 goes away and becomes a 10, and this 4 goes away and we double it to an 8. Now if we doubled everything correctly, everything should still be balanced. 2 times 5 is 10 carbons, 10 carbons. Let's check the hydrogens. So this would be 7 plus 1 is 8 hydrogens plus 2 is 16. 8 times 2 is 16. On the right, we here have 8 times 2, 16 hydrogens. Okay, now let's check our oxygens again. I have 10 times 2, that's 20 oxygens plus 8. It's 28 oxygens. On the right, I have 2 oxygens plus these 2 is 4. So I need to put a number here and a coefficient here so that when I multiply it by 2 and add 2 to it, I'll get 28. So I want this to be 26. So when I add 2, I get 28. So What times 2 is 26? Well, that's 13. 13 times 2 is 26, plus 2 is 28. 28 oxygens on the left, 28 oxygens on the right. So we show that chemical reactions obey the law of conservation of mass by writing a balanced equation. You always have to write a chemical equation that is balanced in order to show this. And this is often a question on the New York State Regents. This is done by writing coefficients in front of our reactants and products. If there's an equal number of atoms on the left and the right, then the masses will equal, and that will show that no mass was created and no mass was destroyed. This takes lots of practice. If you're having trouble with this right now, don't worry. We're going to practice this a lot in class. By the end of this chapter, you will be really good at balancing chemical equations, I promise.